Okay, let it. So what is what's the polarities I give for 2 and 3 then? What's the
Sir, your screen not visible, sir.
sorry, screen is not visible. Okay, one second.
Screen
Yeah,
sharing.
I think is it visible now?
Yes, sir.
Fine, fine. Okay. Now what is the direction? What is the polarity we give for 2 and 3 here? We gave it for positive for 5. What about 2 and 3? Polarities for 2 and 3 here. 2 and 3. 2 is
2
positive.
positive,
Yeah.
3 negative.
3 negative. Okay. We also similarly we write it for I3 as well. So that is for loop 3. So what are the elements or what is the branches, twigs and links that are involved is only 2, 3 and 4, 3 and 6, right? 3 and 6 are only 2 branches or twigs involved. So the rest are 0. And somehow the link is 6, so you'll get it as plus. What about 3?
Minus.
Yeah,
Negative.
negative. See, there is no rule that there should be plus and minus, yeah, definitely plus and minus in the same row or column, right? We are not following that rule. We have a simple rule that follow the direction of the currents. If they are same, give it plus. If they are opposite, give the minus. That's it. Am I clear with this dissect matrix?
Yes, sir.
Yeah. You have one more topic left, that is cut set matrix. So this is what we have written, right? The same matrix which we did, which I have written here is this, right? So what's the represent? Sorry, I forgot to say this. So what's the representation for dissect matrix? We represent it with B. We are representing incidence with A. Yeah, loop of, okay, the direction of loop current is same as the link current. It is given from the oriented graph, right? See here, we have drawn a oriented graph first, right? For this oriented graph, we have drawn a tree first, this red color tree. And we have taken the links which are missing from the tree. So oriented graph have a direction, right? We take the same direction for the links, and we take the same direction of the link current, say, for the loop current. Is that okay? Am I clear with this? The directions start from the oriented graph itself. Okay. Okay. So we have small topic left. We'll just conclude this, right? We can have 2 more minutes. So what is the cut set matrix? Cut set matrix is indicated by Q. So how do you draw a cut set matrix? Is just like same. See how you have drawn a dissect matrix. For conditions for dissect matrix is same as that for cut set matrix as well. What is the condition is that we should have a tree, and the rest of the circuit has to be filled by links, and we can have these loops. See what the rows are defined here. How the rows are defined here? The number of rows are defined by number of links, right? Number of links or loop currents, right? So have 3 links, so have 3 loop currents, so have 3 rows. What happens in a cut set matrix is cut set matrix is defined by number of nodes, right? With only one twig and any number of links. See, forget about these cross lines. See, this is a tree, right? This A 1, 2, 3 has formed a tree. 4, 5, 6 has formed a are the links, right? Suppose for drawing a cut set, for considering it as a cut set, what's the condition we should have? At a node A, it should be having only one twig and any number of links, right? So I can consider this as a cut set line where what's the condition? The condition to be satisfied that it should have only one link, a twig, right? What about the node D? Can I consider this as a cut set matrix for cut set matrix? Can I
Yeah.
consider it as a cut set because see at this node have three twigs. Only our condition is we should have only one twig. Only I think it has to only one twig, right? So we have three twigs, so I can't consider this as a cut set. So I can consider A as a cut set. What about B? Can I consider this as a cut set here? Because I said that number of links I have two and number of twigs I have is only one. So I can use this right? Yes or no?
Yes, sir.
Yeah. What about C? I have one twig and two links. Even then I can consider it as a cut set. Is that okay?
Yes, sir.
Yeah. Now you consider them as, yeah, we can consider them as C1, C2, C3. The cut set has it node as 1, node B as C2 and node C as C3. You can consider in the reverse order, whatever the proportion you have, C1, C2, C3 or whatever, right? So the number of rows in a cut set matrix Q are defined by the number of nodes that are available with only one twig and uh, one or many links, right? So I'll write it as C1, C2, C3 here. And what are the branches I have is 6 branches, right? So what's the direction? See, the directions for this, what are the, whatever the link, tweaks or links that are connected to node A are given value of 1 and rest of them are given 0, right? Rest of them given 0 because the nodes, the tweaks or links which are connecting the node A are only 1 and 4. So I'm giving one below 1 and one below 4 and rest of them I'm giving 0, right? 2, 3, 5, 6, I can write them as 0. And why the polarity is given minus for 4? Because in this cut set, right? In this cut set, we can give the polarity for currents which are coming towards the node as positive and moving away from the node as negative. This is what we need to remember because it's just opposite to that of others, right? Just like in incidence matrix, we are giving opposite that in the cut set matrix, isn't it? Moving towards the node, we gave negative and away we got it as positive, right? Now what you are doing here in this, we are giving minus sign for the current we're moving away from the node and for positive current for the current which is coming towards the node, right? Similarly for cut set 2, what are the elements that are participating here is twig 2, link 4 and 5. So twig 2, node 4 and 5 are given 1 values and the other nodes, other branches are given 0 here. And why do I give plus for 2 and 4 and minus for 5? Because the currents are incoming for node B from 2 and 4, whereas current is outgoing for branch or link 5, right? So we give a negative polarity. Is that okay? Is that clear?
Yes, sir.
Yeah, for cut set 3, see all the three currents, what is the branches which are participating is 3, 5 and 6, right? 3, 5 and 6. All the currents are incoming, so I gave it them as positive. So this is how you draw the cut set. Am I clear with this? So how you draw a tie set, how to draw a cut set? So we have discussed about tie set, incidence matrix in the last class. But how you draw a tie set matrix and a cut set matrix? Die set matrix, we take the direction of the we draw a tree, we take a tree and we complete the oriented graph with the links where the tree peaks are not available, and we draw the loop currents in the direction of the branch currents of the links, and we will take them as the row components, and we'll write the die set matrix. Whereas in a cut set matrix, what we are doing? We'll consider the nodes which are having only one tree associated, and we will take them as number of rows, and we will give the polarity for incoming current as positive and outgoing current as negative, and we'll finish the exact balance. Is that clear? We'll discuss what's the application of these matrices, how do you use them for calculating or analyzing the complex circuits in the next class. Am I clear with this? If you have any doubts, you can ask me. Ma'am is waiting for class. So if you have no doubts, I will be leaving. Is that okay?